Hi, it's Mr. Hanna here. We're looking now at the next topic in our Year 11 Methods course on relations, functions, and transformations. Okay, first thing we're going to be looking at is set notation. So first let's define a couple of sets. Let's define the set A. So we use capital letters to represent our sets. So set A, let's just make something up, and we use these braces or curly brackets. So maybe a hack of that. Okay, curly brackets to represent all the things in that set. So let's make the set A to be 1, 2, 3, 4. Let's make another set B, to contain the elements 1 and 2. And I'll make the set C to contain the elements 2, 4, and 6. Okay, so we need to know with set notation. We're going to learn about a lot of different symbols that make up set notation, and they're all quite important. So the first one we're going to learn about is this one here. It's a special way of writing a Greek epsilon, and basically that one means is an element of. Is an element of. So for example, I could say that the number 1 is an element of set A. So 1 is an element of set A. Or I could say that 2 and 4 are elements of set A. I could also say that 2 and 4 is also element of this set C over here. They're both in that as well. So they're both in set C. Or I could say I noticed that everything in B, 1 and 2, is in set A. So I could say that set B is actually within set A. But there's actually a neater way to do this if we're referring to two sets. And that is to use this other symbol here, which is called subset. So that means a subset is a set that's within something else, but the other thing may have other things as well. So B has 1 and 2, A has 1 and 2, and A also has 3 and 4. So you can say that B is a subset of A. Oops. Subset of A. So B is contained within A, if you like. You notice here that C is not a subset of A, because C's got 6 in it, and A does not have 6 in it. So C is not a subset of A. If ever you want to say not, then you just put a line through it. So it'll also work using the is an element of. So I see that say 10 is not an element of A, so I can write 10 is not an element of A, just like that. Now, in maths, most things have an opposite. So subset also has an opposite, which is called superset. So if B is a subset of A, that means A is a superset of B. Now you just see that this superset symbol is reversed. So that's a superset. So it's basically just the opposite of the subset. Now the subset is far, far more common, and it's the thing that you need to remember. So remember subset. You don't really need to bother remembering superset. Don't need to bother, but you just need to know that it is out there. So there's that. A couple of extra things. First, this backslash means excluding. Excluding. So, for example, if I want just the number 4, I could say, or suppose I want the number 4 and 6. I could say that is C excluding the number 2. Oops. So C, everything in C except for the number 2 is the set 4 and 6. So excluding means not in there. You can also do an easier to look at example. Let's say this set 9, 10, and 11, excluding 9. Well, excluding 9, it just means 10 and 11. 10 and 11. There we go. Okay, lastly we've got the null set. Oh, not quite lastly actually, sorry. So the null set is 0 with a dash through it. means the null set. Null set. In other words, it's a set with nothing in there. So imagine we've got the set B, and then I've said excluding 1 and 2. Well, B is only 1 and 2. So if you take 1 and 2 out, you get nothing left, or the null set left over. Okay, now last two symbols, and these last two hopefully you know from probability. We've got this one, which is an intersection. The intersection, and we've got this one, which is the union. I usually remember these because the union looks a little bit like a big capital U, and the intersection is obviously the other one, which looks like a, I don't know, hill or something. Okay, now an intersection basically just means and union basically just means or. So let's have a look at how that works. For an intersection, let's have the intersection of B, so the B intersection with C. So it means what is in B and in C. B and C. So the only thing that's both in B and is in C is the 2. The 2 is the only thing in both of them. So the only thing in both of them is 2. There we go. If you wanted to do something like the intersection of A and C, A intersection C, so it's in A and in C. 1's only in A, so it can't be 1. 2's in both of them, so 2. 2's in both. 3 is only in A. 4 is in both of them. And 6 is only in C. So 2 and 4 for that. Okay, now on to union. Union means or, so it basically means what's in one or the other. So if we have B union of C, we've just got everything that appears in one of them or the other one. So 1 appears, and then 2 is in B. We've already got 2. Now 4 is in C, and 6 is in C. 6. So there we go, that's the union. Now these two things people often represent with Venn diagrams. So here's a quick one, B and C. So basically this middle bit here will represent the intersection. So if that's 2 for B and C, because 2 appears both in B and in C. Now if we put all of the other elements in, so B's also got 1, and C has 4 and 6. So you can see the intersection is this middle part here. That's the intersection. The intersection is in that middle bit. And the union is the whole thing. So there we go, there's set notation for you.